Are we live yet?
Yep.
Hi, everyone.
Hello. My name is Eva Howe, and I am with ThisDot, and I want to welcome you today to GraphQL Fireside Chats. It is co-hosted by ThisDot Media and Hasura, and our sponsors are also ThisDot Media and Hasura today. We have a couple of upcoming events that we wanted to let y'all know about. We have a global React meetup, which is going to be the state of React, with one of the React core team members, who I'm completely blanking on his name right now, but it's supposed to be super awesome. And then we also have a Vue meetup coming up on May 21st. So we'd love to have you all attend that. Today the pictures are not quite right. Anyway, we've got a couple of lovely guests for you. So I will hand it over to Tanmai right now.
Hello, everyone. Great. So happy that you could join us, and so happy for our panelists to be here as well. Hope you all are doing safe and healthy and are not losing your mind with the cabin fever. Hopefully this is going to be a very interesting chat about GraphQL and serverless, and all sorts of things related to GraphQL and serverless. So before we kind of dive in, would be great to kind of get a quick round of introductions from Simona and Chris, and talk a little bit about what kind of stuff they've been working on, and then I'll kick things off with a quick introduction. I'm Tanmai. I'm the founder at Hasura. We stumbled into GraphQL and serverless both. I used to be very passionately against GraphQL and serverless both, and I've had a nice 180 degree that's kind of happened over the last few years as I've started to realize and understand the kind of interplay of ergonomics and economics that makes GraphQL and serverless very valuable, and hopefully we'll touch upon a few of those things. We've been doing a lot of interesting work with GraphQL and making serverless easy at Hasura, and a lot of the questions that I have for our panelists, and a lot of the discussions that we'll have are kind of motivated by those questions and insights and experiences with our users and with the community at large. With that said, Simona would love a quick introduction and what kind of stuff you've been working on with GraphQL and or serverless over the last few years.
Yeah, sure. Hi, Tanmai, and hi, everyone. Thank you so much for joining us. I am really, truly excited to be here and share some of the awesome stuff that we can all achieve with serverless. I work at Microsoft. I'm a cloud developer advocate, and I've been part of the serverless community probably over the past 2 or 3 years. I think back when I joined Microsoft 3 years ago, Azure Functions was just at the time where they were getting ready to release Azure Functions version 2. And it was really, really exciting to get to experience and be part of that journey, especially because that's when they introduced the cross-platform support and the ability to run and debug serverless applications in your local environment, which, I mean, now that I say it, it sounds crazy, but just before that, a lot of folks weren't able to, you wouldn't be able to run your code and debug your code in local. You would actually have to maybe print statements and kind of maybe run your code locally, deploy it, and then just hope for the best. But generally, yeah, it was very, very exciting to be part of that particular journey. I think probably 2018 was the time when I joined the Serverless Days London co-organizing team, and I started helping out there as well and getting more and more connected to the London and the UK serverless community. And yeah, just happy to be here.
Thanks, Simona. Chris?
Thank you, Tanmai. It's really exciting to be here. And my name is Nwamba, and I'm a senior cloud advocate at Microsoft. It happens to be that this is one of those events or one of those times where I'm participating in a community event with my manager. So for everyone that doesn't know, Simona is my manager at Microsoft. Yes. So right now, like normally I should be nervous about talking to people, but I'm nervous for a whole different reason. because I have to say the right things in front of my manager and stuff like that.
You added a whole new dimension to this conversation, Chris. This is I did not know this. This is going to be amazingly fun.
I'm happy this is recorded, just so.
Yeah. So recently I've been working on this thing called HEM. So it's a research-based project in partnership with Hasura to see how far serverless and GraphQL can go when it comes to working together. And it's been a very powerful experience. And most of the things I learned working on this project, I think I'll be sharing in this fireside chat. And I'm happy to bring all those things to the table, talk about the challenges, talk about like the amazing things that we can achieve with them, and yeah.
That's awesome. And I think I think so roughly I was thinking that the way we would kind of structure our conversation over the next few minutes would be to kind of talk a little bit about serverless first, then we'll talk a little bit about GraphQL, and then we'll talk a little bit about GraphQL and serverless, and then kind of explore the different the good things and the bad things and the painful things, and what lessons we can kind of take away. So maybe to kind of get started with serverless, right? It'd be interesting to hear what kind of applications you're seeing, what kind of use cases you're seeing with serverless, where most of the activity around serverless is around, and where most of the kind of where the ROI with serverless has been very has been as has been as well realized as possible, right? Apart from kind of to separate out the hype from actual applications running in production, or even if they're small applications, right? But basically having a fairly tangible ROI over whatever we had before. And before we get into that, it'd be nice to kind of separate, like have a kind of clear view of what we're talking about when we say serverless. So that would also kind of help, because serverless itself has become a fairly large and kind of broad term that means lots of different things, all good things, but lots of different things. So it's kind of useful to just separate that out a little bit. So the way I think about serverless in particular for this conversation is thinking about serverless functions, and thinking about kind of serverless deployment style, where it's on demand kind of deployment, and the economics are pay per use, as opposed to renting a system, or renting compute, or renting infrastructure that you pay for regardless of usage. And that's kind of the way I think about serverless. But Simona, would love to hear kind of how you think about the serverless ecosystem, what the different things are, and then kind of zoom in a little bit into serverless compute, and talk about like the different ways of separating and grading out the way you look at the serverless spectrum.
Yeah, of course, and I do love how you basically summarize what is serverless in like 3 very, very, very important items, and I think you nailed it down there, where you said that, hey, this is such a broad concept, and not only that it's a broad concept, it's also a concept that has been defined and redefined in different ways by different thought leaders that are in the serverless community. But I think I do agree that when we think about serverless, there's the 3 things that are key, which is we're looking at an event-driven platform where you consume only the infrastructure and the compute that you actually need, and then you only pay for the resources that you end up using. Another aspect of that I think is critical to actually enabling all of these properties of serverless is also, from my perspective, the concept of backend as a service. So I think we wouldn't have ever been able to achieve this kind of success with serverless platforms and functions as a service if we wouldn't have had the support of different services, and particularly managed services. So when we think about managed storage, or managed authentication, or managed event-driven or service buses and messaging platforms, I think those are the ones that are truly enabling the power of serverless. And many times people will talk about serverless functions as being the glue code, between all of these managed services that together give us the capabilities and the scalability that we actually need when we're building applications.
That I think that's a really good description, Simona, and I really like the fact that I think those two kind of tenets are really important, right? When we're thinking about serverless compute, where we're thinking about you need to have it plays well with event-driven systems, because that kind of naturally fits in well with this on-demand nature of serverless. And the other part, that serverless compute kind of relies on the fact that a lot of other things are already servicified in your in the kind of the overall backend or the application that you're looking at, right? Where authentication needs to be or should be servicified, and data should be servicified, or events should be servicified, so that kind of consuming across these services becomes easier. And I think those two are very important aspects. How do you think about when it comes to serverless compute? How do you think about serverless compute as are you particularly opinionated about the fact that, for example, everything must be a small function, and a small function must be deployed, and that's a serverless function? Or do you think of serverless, for example, as a way of as a deployment model, and saying what is deployed isn't important as long as it is invoked on demand? And so, for example, things like Cloud Run, that where you have or with Knative, right, where you have, or even OpenFast for that example, where you have a Docker container, and you're still thinking of your application as containers, but it's getting deployed as if it was a serverless function, like on demand, right? How do you think about that?
Yeah, I love this question, and this is actually something that I do mention in some of my talks, and in some of the conversations that I have with developers and companies out there. I think that when we look at the deployment model and how we should think about our code, thinking through the single responsibility principle, I think that's important. And I love that serverless actually enables us to do that. One of the things that I learned very early on in my developer experience or developer journey is that if you deploy your code as a monolith, then everything is going to be very tightly coupled, and then you're going to have to provision for all that tightly coupled code. And I mean, the classical example of maybe your page for viewing products or for a certain product will be accessed millions of times, whereas people are not necessarily creating accounts as fast or as much as they are viewing products, which means that when we look at how we couple those two services, or how we actually decouple them, and then how we make sure that they are deployed in separate instances, because that's what serverless allows you to do as well, right? It has this elasticity embedded into the platform and auto scalability, and we want to make sure that we can benefit out of this just by making sure that we decouple some of our components of our application, and we have a clear understanding of, hey, this is how my separate components, this is how my users use my application, this is how it translates into components that are part of my application, and this is how I want to deploy them independently. And then the other aspect of how you deploy your code is not only like how it scales, but also how you actually deploy it, right? You don't want to have to redeploy your entire application that has, let's say, both components related, like products and customer management, just because you had to change something in one of them. Ideally, you want to deploy them separately. And this is very, I guess that anyone that works with microservices, this sounds very familiar. The way I like to think about functions is just nano services.
Got it. That's exactly what I was going to ask you next. Is like there's a spectrum of like monolith microservices, and then serverless functions are kind of like hyper microservices or nano services. So that makes sense. And sorry, go ahead.
There's also this other risk of, because with functions you can deploy just as many functions as you want to, there's also this other risk of proliferation of functions where you have very, 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 very tiny functions, and then they're being deployed independently, but it's much more harder to reason about the relationship between them and really where my code is and where's my application being deployed. So I think there has to be a good balance there in understanding how you decouple or couple parts of your application.
Got it. Makes sense. And Chris, like when you've been kind of over the last, as you've been kind of getting into serverless, what is, how did you kind of get into serverless, and how did you kind of come across serverless? And then second, what kinds of use cases have you seen with serverless that you've especially enjoyed?
Yeah, I've always been a stack type of developer, and kind of like I have to like work with either mean or men or lamp, kind of yeah, stack in the past. So one of my mentors, who happens to be Sarah Dressner, I kind of just like stalk her posts just for fun. And I started seeing a lot of articles on serverless functions, so I decided to give it a go. Now, what basically like just my first the first time I laid my hands on functions, it entirely changed the way I thought about building applications. And this was because every single time I wanted to set up an app, maybe I just want to build a simple browser-based game, just a very simple snake game, for example. But this snake game should be able to just track high scores and just save those high scores so people can just compete. And yeah, and then I realized that I just need one table and one function, like just one table and one HTTP URL that saves that saves to the leaderboard. But then to do this, I would create a mean. I will go use something like Yo generator or any of those generators to create a full-fledged React plus Express plus Node plus everything app. And then I end up like only with just one endpoint in that whole stack. So I I I still realizing that all I just needed to do was just build your front end with just something as simple as React or Next, Vue or Next, and then I started writing functions that just, in fact, in this case, just a function that would send to deploy to Azure function. And guess what? Uh, none of those fun projects have ever cost me money in deployment, but every single time I had to set up, most of the hosting providers I used like have flat monthly fees and stuff like that. But with functions, I could push functions and push static sites. Because the game is going to end up being a static site. Push both of them to hosting providers that don't charge me anything. So that's where like my whole view about how I was building my apps changed, and I started like approaching the whole serverless thing more and more. And another inspiration was the fact that, yeah, I'm a front end developer. I really like to like hack what happens in the front end part of things, and that's a lot of work. There's aesthetics, there's optimization, there's a lot of things to do in the front end aspect of building apps. But then, as an independent developer back then, I needed to always have some way to store my data, some way to something to serve as a backend for whatever fun or whatever serious front end project I'm working on. And most of the time, it took me learning about architecture I don't need to know about, learning about like really how to deploy stuff, how to scale them, what's the best pricing, what should I be looking out for. But basically, like the auto scaling feature of serverless, the fact that it's basically sleeps when you're not using it, and all those kind of features. So I think I don't have to worry about anymore, because I'm not, it's no longer a monolith anymore. It's this decentralized system, or decentralized style of building up applications. So that's basically what got me into using serverless.
Got it. So kind of like it started off with just the joy and the ergonomics of like being able to say, this is code that needs to run,
Yeah.
and the easiest way of just having it run, right? And then from there it kind of grew into the fact that also I only have to pay for it when it runs, right? And that's a powerful feeling, right? That's a very like powerful enabling feeling. And I think that's kind of one of the things that really changed the way I think about serverless as well, because I used to kind of come from this, I was completely absolutely guilty of like the kind of like, oh, no, serverless doesn't make any sense. It's useless. It's this vendor lock-in. There's like whatever. I can't use my favorite libraries. I can't use my favorite tools. I can't do this. I can't store state. I can't whatever. And then I realized, wait, no. If I don't do all of those things, what I get to be able to do is just write code and have it like, quote unquote, scale forever and, only pay for it when I do, when I need to. And I think for me, that shift in the mental model of saying that, when you think about a backend, right, like an application backend, that application backend is a certain amount of business logic that deals with state. And what serverless kind of forces you to do in a way is it forces your state to be it forces that to it forces your business logic and your state to kind of separate in almost like what you would have done in a best practices way almost sometimes, but it kind of forces that on you. And then because you do that, things become easier, like things like scaling or whatever, those kinds of aspects, and it becomes easier for vendors also, like the serverless vendors also, to kind of give you the pay-per-use economics, right? And I think that was something that that really kind of blew my mind, of saying that we can constrain the system so that we can get like non-functional benefits guaranteed, right? And it's a really bad analogy, but like a lot of the code that we write is written in Haskell, and one of the things that you do in Haskell is that you kind of separate the way you deal with IO from the rest of the code, right? And it's very explicit. It's kind of like you have to be very careful about the fact that where you're doing IO, you have to explicitly mark that and take special care of the fact that you're doing IO in a function, and the rest of it is pure code. Now, if you're designing an application, you would, or you're building a system, you would do that anyway, right? You would start separating out like pure testable units of your application from the IO portions. And to me, the mental model shift to serverless seemed very reminiscent of that, where it's kind of forcing me to say, servicify the state elements. Don't explicitly deal with state, and try to like delegate that to other systems, but deal with kind of business logic, and that will free you in a sense, right? So that was kind of really mind blowing for me, and kind of what convinced me that serverless makes a lot of sense, and really kind of accelerates productivity, right? What kind of use cases, Simona, have you seen that are not just APIs on serverless, right? Especially with like with must be interacting with quite a few folks, especially the at serverless days and stuff like that, to see what kinds of use cases are people what kind of things are people building with serverless that is not it's not just the API that needs to do something for an application, but could be other kinds of tasks. Or and if you do see that, what kind of split are you seeing in usage and adoption of serverless for solving different kinds of problems? One would be like, say, an API problem, or like a glue between two different services that is not invoked on APIs but invoked on events, that kind of stuff.
Absolutely. I think one of my favorite use cases that I didn't really find it highly documented in any of the places that are at least familiar to me, but it was posted on a Reddit thread, and I believe absolutely everything that's being posted on Reddit. Who doesn't, right? But that was, I thought that was like the perfect example of incredible scale, and taking like benefits from what serverless is capable of. And I'm creating a lot of tension before I actually say what the use case is. But it's actually when you're in the London Underground and you are tapping your card to pay your journey and to enter the Underground, that's actually running an Azure function. That was like, my mind was blown when I read that. I thought that was a great example of how you can use serverless at its best, having tons, like thousands of devices being connected. Another thing that we haven't discussed about at all in terms of serverless is this concept of cold start, which is something that everyone will probably experience as you get started with serverless, where it's that amount of time that it takes for the provider to take your code from a storage account into a container that's being deployed, and it runs your code. So when it comes to actually activating that payment for your trip, it doesn't really matter whether it's being deployed, or you're paying within seconds or nanoseconds. So I thought that was a really great example. Generally, what we're seeing is that a lot of folks are getting started with serverless. In particular with APIs, that's like the point of start, and that's the majority. I think more than half of the folks that are getting started with functions, they create APIs, and I think that's because it's easy to put out their application, create an API, test it, and you get a feel for it. That's being facilitated as well by the fact that there's all sorts of, like, when you use the browser to create those functions, when you can test it very easily and you get feedback immediately. Once you get familiar, a lot of the enterprise customers are actually using serverless for IoT scenarios. So I think we have a lot of customers that are using serverless to listen for events that are happening, maybe in agriculture or in cars, and other many examples. But it's a great example, again, where a use case where serverless can be very useful.
And so to kind of just map that architecture mentally, it's something like you have several IoT devices, or you have like real life physical things, right? And they're emitting events, and those events are being kind of ingested, let's say, into some kind of a queue on the back as quickly as possible. And then that the events from that queue are gradually being consumed by serverless functions, depending on, like, let's say, the rate at which you're consuming or the size of the queue or whatever. And then that kind of execution is happening on the back, right? So kind of like, and so people in real life are not particularly worried about when it executes or what happens, because from their point of view, it's like, I've created this event and I expect this event to be fulfilled. You figure out how you're going to do that, but from like a end user point of view or a device point of view, it's basically just emitting events. So okay, that makes a lot of sense.
Yeah, and then another type of use case that it's quite common is actually defining workflows. And this goes back a bit to what you were saying earlier in terms of state, where ideally with serverless, you would want to be able to do to coordinate long-running tasks, for example. So think about your CI/CD process, or another good example that I'm very excited about is being able to maybe train some of your machine learning models using serverless. These are tasks that can run for a very long time, but you want to be able to orchestrate and coordinate them and trigger certain events so that they can start and then get back to the next step that's relevant for your particular workflow.
Got it. That makes sense.
And there's actually a flavor of Azure functions that basically does all this. It's called durable functions. So basically, I like to call it. I like to refer to it as the function that remembers. So it's just like the name is. It's durable. There's durability. There's state. So it's kind of like, imagine a function that executes. It sends back a response, but then it goes ahead to like do other stuff, and then the first response is going to send to you is a response with a status URL. So that status URL would always send back a JSON payload of what's going on, how long has it taken, how long would it take for it to complete, and stuff like that. And you can monitor like long running tasks without having to keep the user waiting, and you can always ping an endpoint to see how far has this request gone with executing. And this is very powerful for handling things like notifications. I wrote an article on CSS tricks on how to build a calendar. It's like a Outlook or Google Calendar clone with durable functions, where you basically like create a task, and then that task goes and gets scheduled so that you get reminded later in the future about what you have to do.
Got it. Makes sense. And I think like that kind of that kind of also leads to some interesting kind of tooling that's emerging around, almost like, I think it used to be called like the BPM category of tools, right? Like business process or like workflow kind of tools, right? Where you kind of put things together. The overall workflow is kind of a long workflow, but it's run through a sequence of steps where it's the same function that's running again and again, or it's checkpointing, or it's like running different functions. And so it's going to be, I think, I think that's going to be very interesting. There's a lot of like work that's happening in that in that area, so that's going to be very interesting to see. It's going to make a lot of different kinds of serverless applications more easy and kind of more real. So I think that's kind of a great overview of serverless. And kind of switching gears to GraphQL a little bit. One of the things that so for example, I mean, obviously everyone who's here is kind of fairly aware of GraphQL. Everyone listening to this chat is also fairly aware of GraphQL Fireside Chat. So but otherwise, I think so what I'll kind of do is maybe set the context a little bit with GraphQL and serverless, and then we'll talk a little bit about different approaches that we can take. So one of the things with GraphQL is that GraphQL is essentially a type system that kind of describes your API, right? It's a set of types, and the types together describe your entire API. And just as you would kind of imagine, the best way to build a system that is essentially a system of types that work together would be kind of a monolith, right? Because if you're thinking about types, right, they're usually within the same code base, right? And then whenever you do something or you change the way a particular type works, another type breaks, right? And so everything is coherent across your type system, right? And that kind of thought process maps really well to the way a monolith works, right? Because you're basically adding more and more types as your functionality evolves, or you're evolving these types in a way that don't break each other, right? And it works really well with a monolithic kind of style of thinking and a style of deploying. I don't know what the exact correlation to this is because of GraphQL being developed at Facebook, of course, but which we know is a monolith that is running at scale, I mean, sort of monolith running at scale, and so GraphQL kind of has that property, and this is what makes GraphQL very desirable for API consumers, because for them also they get to view an API that is coherent and can be consumed at a single endpoint, say. The kind of story with GraphQL and serverless, though, is interesting. I don't want to use another word. I just want to say interesting, right? So it is interesting for several reasons. The first is naturally the fact that you first have to change your mental model a little bit to think about like how you would deploy a monolith versus how your deployment is going to change when you deploy serverless functions, right? So for example, we talked about two kinds of ways of deploying serverless functions, right? We said you kind of deploy a monolith, which is a set of functions, and then you run that in a serverless on-demand kind of way, right? And the other is kind of like the nano service model, where you try to separate each concern as much as possible, which is like each function exposes kind of that type that it is handling, right? But then somehow all of these kind of have to come together, and this is a unique problem to APIs, right? It's not so much of a problem when you think about serverless running for events, right? But it becomes the problem gets magnified when you think about serverless APIs and GraphQL APIs. And so I'd like to maybe spend a little bit of time just talking about like how we can kind of resolve that dichotomy when we think about GraphQL monoliths and serverless functions, and then get into a few specifics about what kinds of challenges we're facing. So Simona, I know you're not extremely familiar with GraphQL, but from that kind of intro that I gave you with GraphQL and serverless, what are your thoughts so far?
Yeah, I think one of the ways I like to work with serverless and GraphQL is in a way in which my GraphQL function and my single GraphQL endpoint, it's actually as a wrapper on top of our serverless functions. And the reason why I do like this approach is because one of the things that I really love about GraphQL is the fact that it's documenting my APIs, and it's documenting the capabilities of my APIs. And I think as we deploy more and more functions, we lose that understanding of what are my endpoints and what are the capabilities around my endpoints. So whenever we have this very thin layer of our GraphQL endpoint on top of existing services, it just helps me reason about my application very easily. And I think that also helps a lot with basically maintaining those concerns and maintaining those use cases separate, not use cases, but like parts of our applications are separate, deployed in different serverless services or functions. And then we have the GraphQL API that basically brings everything together.
Got it. So basically, you're thinking of it as like there's a kind of a separate GraphQL wrapper service, and then that's kind of backed by serverless functions that might be executing actual business logic. Is that is that right? Okay,
Yeah.
awesome. Got it. That makes sense. I think that's kind of an approach that I feel comfortable with as well, because one of the challenges has been that if you think about, like, GraphQL has so many uh, running a GraphQL server in production is so much more involved than running a REST API in production, right? Like, for example, you need to cache a query plan. You might have like a query plan that is like executing lots of things, and computing that query plan every time a query comes in is very expensive. And so you might want to cache that or for a certain amount of time, or might want to memorize certain pieces of data or certain data sources across different requests or within the life cycle of a request, because you know that it's going to fetch the same data again, right? And all of those kinds of optimizations become easier to do in a more traditional kind of forever running service, rather than in the serverless model, where you're thinking more of input and output, and the serverless function is stateless, right? And so that's kind of been my thought process there, as well. Chris, anything that you'd like to kind of add to the your experiences with having GraphQL APIs and serverless, and how you like to think about them?
Yeah, so just like you mentioned, it's a different. They're two different mental models, but one thing I've really got to find a very, very nice sweet spot between them. Okay, so basically, GraphQL is, of course, it's a graph system, and it's made up of nodes.
I can hear you. Your audio was a little bit patchy in the middle. But
I
are you
think I
back?
lost you all for a minute.
Okay.
Yeah.
Yeah.
Okay. Cool. Yeah. So GraphQL is made up of graph. It's a graph, and it's made up of nodes, and that. Okay. Cool. Yeah. And that makes it even more difficult to decentralize. It has to be a monolithic system. Yeah. But what one philosophy I have is, I always say, give data to GraphQL and give logic to serverless, kind of thing. So that's like the what like when people like ask me, hey, how do I, like, that's just my one line question. But basically what's happening is, and this also became very clear to me when I worked with Hasura a lot, and I realized how your team how your team like managed to differentiate between both of them. But what I basically do is that if I have this repetitive data handling or data management system like CMS and stuff like that, I would drop them into GraphQL. But what happens when I just, like, users are not going to always send payments. Users are not always going to send have reasons that would trigger them to send emails. So logics like that don't generally fit in a bigger architecture, a bigger like box of CMS. They're just one of logic that needs to be handled once, and then that's all. So I basically just plug in serverless at those points, those kind of logic that needs to be handled for unique purposes that are not primarily my not primarily my business model. I kind of just extend them using serverless
Got it.
and it kind of yeah, exactly, it kind of makes it more easier to decentralize and reuse logic across different GraphQL code. Because if I wanted to, for example, if I wanted to probably send an email, send a welcome email, both when a user signs up or when some other thing happens, maybe like a user that's been out for a long time comes back, that kind of thing. I don't have to it's just going to be calling an API that seems like it would feel like I'm using a third-party API to do this, but basically I'm still like using a serverless function I wrote.
Got it. Yeah, I think that's kind of the approach that we've seen success with as well, which is to kind of separate that GraphQL and data concern from the business logic concern, right? And to allow kind of best of breed in both of those things to happen without getting bottlenecked at the GraphQL layer as well. So that approach has been very interesting. I think some of the related things that we're kind of excited about there, and the way we think about it is basically to say that one of the things that make GraphQL and serverless very exciting is the fact that for example, the event kind of IoT use case that Simona was talking about, where you have events that are registered, and those events then trigger some kind of logic that happens in the back, right? Like a subtraction from your account because that's the ticket that got swiped once or whatever, right? In those cases, it's not a web application, so I don't the user doesn't need immediate notification, right? But in a lot of these kind of asynchronous event kind of systems, right, that closing the loop with the end user becomes really important. And I feel like GraphQL has a really nice kind of ability to help us close the loop, right? So think of it as maybe an event comes in from somewhere, right? Either it's an API event, or maybe it's an event coming in from an event bus or a queue or something, right? And that event changes state. And then you can have a GraphQL subscription that goes out to the user that helps the user understand that something has changed, right? So instead of thinking of it as kind of a synchronous operation where I make the change, I wait for that response to happen, and I get the response immediately, you can also move selective parts of your application to think of something as here's a mutation, and now I'll subscribe to the mutation result, whenever it comes in. So, if I close the tab, I reopen the tab, I navigate out, I come back, I reconnect from the internet, whatever, it doesn't matter, because ultimately, whenever that result comes in, through all of the resiliency and failure checks and redelivery and all of that stuff that event-driven systems will kind of take care of for you, it's nice to kind of have to kind of give the backend systems that ability to say scale freely, build resilient systems, be event driven, but also kind of create a synchronous, almost a synchronous feeling for your end users using a combination of GraphQL, mutations, queries, and subscriptions, right? And so GraphQL subscriptions in particular excite me a lot when it kind of comes to these event driven applications with GraphQL, and so that's kind of been very interesting. Although, I mean, you can't move all of your applications to this model, but it's nice that some parts of it could kind of move to this.
I'm curious, Tanmai. I really love your observation there, and I'm curious, in your experience, what are some of the challenges that folks encounter when getting started, or not necessarily when getting started, but also when they run into some of the more complex use cases? What are the challenges that they run into with GraphQL and serverless?
Yeah, I think I've seen two kinds of broad, two kinds of challenges, right? The first is that it first depends on your kind of GraphQL approach, right? So you have to choose what GraphQL approach are you going to go for. Are you going to go for GraphQL monolith deployed as one gigantic serverless function? Or are you going to have GraphQL resolvers that are deployed? Each resolver is a separate function. And then you have kind of a GraphQL thing that delegates to different resolvers that need to be composed. And both of them result in different kinds of challenges, right? The first one kind of results in a challenge where you have to be conscious of the size of your function. The underlying, the size of the GraphQL schema that you have, the amount of time that it takes for your GraphQL server to boot itself and validate, those kinds of things you have to bake in those optimizations into your GraphQL server to make sure you don't lose time in just starting up a GraphQL server, preparing all of the data structures to do GraphQL validation and all of that, right? So it increases your kind of start time a little bit. I mean, there are ways to get around it, but you have to be conscious of it, right? On the other end, you kind of, when each function is a resolver, you'll run into this problem where you need to have you need to be very conscious of n+1 executions, right? Where you realize that you're calling, you want to have artists, and each artist has a bunch of albums, and so you're making a query to say, I want the first 10 artists, and for each of those artists, I want their albums. And when you make this query, you'll realize that your GraphQL, your serverless functions are running. It's not one serverless function that's fulfilling this. It's one serverless function to fetch artists. And then if you have 10 artists, you're running one serverless function each to fetch the albums for those artists. And this seems if you put all of that together, the overall latency that you will see for your application of fulfilling this request, as opposed to back in the good old days, I made one SQL query and join because that data is probably together, right? Or I'm making one document fetch from a NoSQL database. It is blazing fast. It is the order of microseconds to fetch that data, right? And from like just a raw disk IO point of view, it's literally in the microseconds to fetch that data. But you've added these layers and this excess execution that suddenly will surface up as seconds, or depending on the size of the data that you're requesting. So you have to kind of be conscious about what kind of approach you're taking. And I think those are kind of the two broad challenges. Now, once you address these challenges, there'll be some other kind of challenges that are unique just to GraphQL that also come in, which are, for example, some of the stuff that I was talking about, which is that having shared memory in GraphQL is very valuable. Because across requests you can do a lot of optimization, and you can memorize or cache data, and this becomes very valuable as you have like multiple GraphQL queries coming in, because if you know that this piece of data is being requested again and again, it might be in the lifetime of that same GraphQL query, or it might be across GraphQL queries. That optimization is just easier to do when you have when you're not thinking in a serverless way. Another example where the serverless API model doesn't fit, and you need to think of it more as a serverless event model that you were talking about, Simona, and less of a serverless API model, becomes like GraphQL subscriptions. So GraphQL subscriptions are also this kind of unique, painful thing where you have WebSockets that map to clients, and the instant you have WebSockets on the server, all bets are off, right? Because everything just goes to everything just becomes a nightmare. Things stop being horizontally scalable, right? I don't know if like the pets versus cattle analogy that used to be thrown around a fair bit a few years ago in the cloud native ecosystem, right? Which is that, do you treat your backend servers as pets? Do they have names, or are they cattle? Are they various containers and they can just run? You can upsize, downsize them. You don't care, right? It's horizontally scalable. Whereas with pets, every single instance of the server has a name, right? So this is server 1. This is server 2 running on this VM. This is server 3 running on this VM. And you have to care. When it comes to WebSockets, right, you have to care about, which server is serving which client, because that subscription stream is being maintained per client, right? So you need to maintain that information. You can't just keep chucking that WebSocket and throwing it to another server. I mean, you can, but you need to do a lot of work to make sure that that can happen. So all of the ways that we think about stateless HTTP servers or scaling servers, right? All of these things become very challenging when it comes to a GraphQL server that needs to have subscriptions that is backed by serverless functions, right? Not to say the core fact that you're missing, the main thing that you're missing is that the serverless function doesn't exist. So when an event comes in, there is nothing that exists to hold the connection to push that data to the client, right? And which is why I think, like, just like the way you were saying, Simona, and what you were saying, Chris, like the idea of having like a GraphQL gateway that handles these GraphQL specific concerns for you, right? The data optimizations, the WebSocket stuff, and lets you deal with the idea of just having serverless business logic that is executed on events, right? It could be an event from a queue, or it could be an API event, right? Whatever that event is becomes much easier to think about. So those are kind of some of the challenges that we've been seeing. Does that make sense? And is that, yeah?
Absolutely. I mean, those are some of those things. I've been meaning to implement subscriptions in Azure Functions for the longest time, and I'm still it's still on my to-do. I promise I have a post-it on my because
I remember when I just joined Microsoft, I was really excited about GraphQL and serverless then, and Simona and I were like the two best friends at Microsoft that are always telling people about serverless and GraphQL, and then that was the one word that we actually hit, and then we were always like worrying people about, hey, why not just make it possible for us to have like real-time stuff on serverless? And people are looking at us like with this weird look, but it's not like an anti-pattern, because
Right.
the point of serverless, their vision for serverless was different from what we were saying, like that kind of thing. So it now became like a whole thing of us trying to find a way around it and stuff like that.
Yeah,
So
yeah. I think that it's going to be like it's very interesting because it's almost as if two systems independently collided, right? There was this system of saying where backend where people who were building applications on kind of quote unquote the backend, right? Were people were moving towards event driven, people were moving towards like more isolation, more separation of memory, right? Like what Simona was talking about by saying that the reason why you sometimes don't want to deploy everything as a monolith is not just because it's sometimes like different people are building different things. It's also because there's shared memory between two different concerns, right? Like if the product page is being visited so often and the customer account page is not something that's visited often, right? If there is a problem in your code, let's say there's a memory leak in one part of your application for no reason whatsoever, it's affecting another part of your application, right? Which sucks, which is like, I don't want to deal with that problem as a developer of that other service, right? And so this was kind of an independent idea that was happening, right, where people were moving towards events and tinier, more isolated execution. And then there was this independent movement that was happening, which was the people who were building applications, especially on the front end, they really just wanted to add backend functionality as well. And they did not want to deal with like provisioning things, right? And like, I don't want to build a server. I don't want to provision a database. I know that there are these SaaS APIs. I can glue them together and build something amazing. And it's like these two collisions kind of met head on, right? And surprisingly, serverless was a great fit for both use cases, right? But then obviously there were like some places where you have to be kind of more conscious of that. And I think GraphQL brings out the worst in serverless APIs, if I can put it that way, right? Because GraphQL is like hyper monolith, and it kind of makes that. But I think I think a lot of that kind of a lot of those problems are getting solved with work that we're doing and work that people are doing on how to kind of separate the GraphQL concerns from business logic. So that's going to be very exciting. What are kind of the other pain points that you have seen with just running with serverless or serverless functions, and things that you're excited about that would make some of those kind of operational elements easier? Chris, or and this is specific to serverless, right? Not necessarily GraphQL and serverless, but just with serverless functions.
Yeah. So one thing I've really, I think Simona mentioned this earlier, is infinite scale, where you have like multiple functions and you have to like, generally I would shout at you if you write, like if you have a monolithic looking function kind of thing. Like if you have like if to me it's an anti-pattern. The point of serverless is just have this one executable function that just does one thing. So, but like if you try to, let's say I decide to go crazy and build an entire CMS with serverless functions that has, there's category, there's create function, read function, update function, delete function for category, there's for product, there's for others, there's for yeah.
I'm sweating.
Yeah.
I'm just like
yeah. So in as much as I'm saying this to you because they're my friends, but out there I'm going to tell people, hey, serverless can do anything you want it to do. But this is one of the weakest points I've seen with it, where like I don't think it's designed for something like this. Okay, the point is that there's still like monolith is best for this kind of problems. But when you
right.
have to like really, when you have to like really like do more event driven kind of processing, or like distribute like just a request for things to get done for you and then they get a response back, that's where I feel like serverless like acts way much better. Because what I'm saying, this is people, I went to a workshop and then the workshop title was affordable serverless. So what I did was I went to the Azure pricing feature for Azure functions, and then I gave them an exercise. I was like, okay, let's start with 10 requests and see how much it costs. It was 0. Let's add one more 0. It's 100 requests. It was still costing 0. Let's add one more 0. 1,000 requests. It was still costing nothing. Let's add till like about 1 million or 2 million requests. That's when they start seeing like very little charges.
Yeah.
So
Makes sense.
this start because it was a startup workshop here. So this startup folks who are looking for how to save money they were now thinking of crazy ways to basically like build the entire the entire system as a serverless. Yeah.
Right.
So yeah, exactly. Yeah. So so that was one of the things I told him to watch out for. You just be it's possible, but just know that beware of shooting yourself on the foot at the end of the day.
Got it. Got it. Got it. Simon, anything to kind of, what kind of things from your experience and, interacting with the serverless ecosystem, things that you're seeing that kind of uh, uh, challenges that, developers and ops people or DevOps people are facing with serverless, and I know what are you excited about in terms of like things that people are doing in the ecosystem that can kind of benefit and solve some of those issues.
Yeah, we've talked a lot about states in this hour, and I think that's one of the things that I'm excited to see more and more, to like more effort to solve some of the challenges here, where we know that serverless is really great when you don't have to share state, but then when it comes to like heavily distributed applications or very heavy machine learning applications, serverless is not a great fit, exactly because you cannot share that state and you cannot share memory in a way that it gives you that really, really fast access and fast response. So I think that if we find a way to push those boundaries and find ways to create a serverless framework and serverless environments that allow you to do both sides of the coin, if that makes sense, that would be really great. But one of the things that I do care very deeply about, and we haven't necessarily talked a lot about, is the fact that serverless also enables us to be greener developers, if that's a way that I can formulate this.
Absolutely.
If we think about how we care more and more about climate and we care more and more about sustainability, serverless actually enables you to consume less and to be a lot more conscious in terms of the impact that you're creating in the world. And I absolutely love that. And I think this is where I do love GraphQL and serverless being put together, because you have serverless that enables us to be conscious of the impact that we're creating onto our planet, but also from a GraphQL perspective, it allows us to be very caring for our users and not consume a lot of the bandwidth that might be critical in many cases. And it reduces the amount of data that we have to pass from our servers to our clients. So those are the two kind of positive things that I think when we're using either GraphQL or serverless or together, we're actually doing better work as developers for our users and for our environment.
Yeah, no, I actually really like that way of you putting that, Simona. That's amazing. It's like that's also what is common about GraphQL and serverless, right? As we're kind of moving forward, like the broader trend of this is use and consume exactly what you need, right? At that, restrict consumption to that limit. That's kind of that overall theme of more efficiency that is coming through with GraphQL and serverless. I think, yeah, that's a really nice way of looking at it. That makes me feel happy about a lot of the compared to a lot of the other like CPU cycles that we're burning on servers. So that's a really nice thing. I think I think. Oh, sorry. Go ahead, Chris.
Just one quick thing. Sorry. Yeah, I know people would argue with Simona about things like because of things like code stats, and I just wanted to say something about it. It's because one of the things that makes functions really greener is the fact that it has this code stat feature where it basically goes to sleep and doesn't use up resources, both like energy resources when what I've always advised people to do in the code stats period is just think ahead of like how your users behave. For example, if when I place an order and you need to send an email to confirm my order and that email is sent to its serverless function, what I would generally do is on the order page while the user is filling out the form. Once I see that the user has gotten to like is checked out and gone through the pain of started filling his or her address, I would basically ping my serverless function to wake up. So before the user gets to the point where they click to actually send an order or like that kind of thing, like the function will be awake and ready to start handling requests. So like if you think ahead of time, wouldn't like I don't personally see code stats as a problem if you're using serverless correctly. Like, I just think, like, if you think ahead of time, and like just make it wake up, and like the way you have to wake up every morning and like have a
Correct.
coffee first. That ping is like giving your function a coffee to drink first before it starts handling your request.
Yeah, I think, and I think like for me that I mean, for me, I think that like one of the nice things that's happening with serverless and GraphQL also is that it's kind of forcing the optimizations to happen in the right places as well, right? Like if, for example, you are generally, even with the way real life users are, right? People like reads to be fast, and they're okay with writes, things that are write actions taking a little time. And as long as they get done eventually, it's fine. You can even show me everything is successful before the result comes in, and it's okay.
Yeah.
And then you can later on send me an email saying that, oh, you know what, your payment failed, by the way, sorry. Like, we talked to your credit card company and the bank and whatever, something failed, it's okay, right? So and so in those cases, if you think about that kind of architecture, it's really like, one of those architectures like the command and query architecture, and we call that like the 3-factor architecture, which is like a variation of command and query to serverless, which is basically this idea that you have serverless commands, like the command, the part of the API that is kind of running the business logic is like a command that goes off into an event-driven workflow, right? Maybe it's one serverless function, maybe it gets into one event bus that's triggering a series of serverless functions or whatever, but eventually they will go and update state. And the part where you're reading that state and querying that state and showing that to the user, that part is where you do most of your kind of optimizations on, right? And make sure that like data is cached effectively, you're doing that well. So then from a user experience point of view, you're kind of running that command, but then whenever you need to run the query to get the result of that command, that is optimized and that is fast. And that can now be, that optimization can be pushed into infrastructure, not code that you write, right? And that's kind of the approach that we've been taking at, with building that kind of GraphQL gateway at Hasura, where the GraphQL gateway is essentially a command and query engine, where mutations are mapped to, like, say, serverless functions. Optionally, some mutations can be mapped to serverless functions, some mutations can go to some other data source. And then they go and update data sources, and then you query from data sources. And that kind of makes that entire loop fast. So your serverless function doesn't have to do the querying. Your serverless function doesn't have to do the data fetch, right? Your serverless function can just do the business logic. So yeah, that's kind of, I think it's going to be very interesting to see how GraphQL and serverless kind of evolve in the coming few months and years. But we're kind of out of time, with it being 2 minutes over time. So before we quickly wrap up, any picks that Simona and Chris, you would like to share? Technical, non-technical, anything? One of my favorite questions to ask is, how are you dealing with lockdown and quarantine? Do you have any interesting quarantine busting tips? Whoever would like to go first.
Yeah, I really like this. I don't know if Simona was going to share it, but there is this tool that Simona shared with me, and it has changed my remote life. It's called Crisp, and you can find it at crisp.io, KRISP.io. So this tool basically, like, I had to like do a brute force test on it, and basically like take my it's what it does, it cancels noise out of your audio input, like any kind of noise. What I did 2 things to test its capacity. I took my laptop and put my tap on and recorded and like that, the entire water flowing went out. Yeah. And the second one I did was, I've been practicing how to DJ, and every time I put on Crisp on, the only audio I get from the sound of the DJ is the vocals. The entire instrument goes away, which is mind blowing. Like,
That's insane.
I'm
How do you spell it again, Chris? How do I spell this? What is the
KRISP.io? I can't thank Simona enough for sharing that tool with me. I don't know where she found it, but she's a lifesaver. Like, I literally have my door open, there are cars driving by, and I'm sure you're not hearing it, but I'm just getting fresh air regardless. Yes.
Got it. Crisp, that's awesome. Yeah. Okay, crisp.ai, right? Is that
Crisp.io,
awesome.
KRISP.io. Yeah.
.io. Okay, awesome. Yeah, that sounds very useful. Simona?
Yeah.
All right, so I'm gonna share my lockdown tip, and this is getting yourself an elliptical that sits under your desk, and while you join remote meetings, you can actually kind of entertain other people because you are exercising while you're speaking, but at the same time, it helps you keep in shape, bring those endorphins and stay happy while you're not allowed to go out. But to a more serious note, one of my picks, I think, not necessarily lockdown related, but it's something that we've been spending a lot of time on, and we're actually very excited about. It's the Microsoft Build conference that's coming up next week. And I know one of your co-founders, Rajoshi, she's joining us next week as on a panel for serverless. So I'd love to kind of share that with everyone that joined us today, that we have a virtual conference that we've all been working on, and we put so much passion into kind of designing the content for that and preparing some of the wonderful sessions that are going to be streamed. And it's a free event, it's virtual, and it's going to be tons of fun.
Awesome. And I can just search for it if I do Microsoft Build 2020, right?
Yes. Yeah.
Awesome.
All right. I'm also sharing the link in the YouTube channel, in the YouTube chat as well.
Perfect. Awesome. And so my picks are I have found a bunch of nice Zoom backgrounds. I am a big fan of Studio Ghibli, which makes really good animated movies. And so Studio Ghibli has put out a really nice set of Zoom backgrounds, which I now use during my calls. I keep switching between different calls so that I have a different background all the time. Makes me feel good. It gives other people entertainment too. It's not quite as good as Simona's elliptical, but it's a little bit, it's close. The other thing that I'd like to quickly plug in is we're also hosting Hasura Con, which is our first user conference in June. So just search for Hasura Con 2020, and we're going to do a lot of exciting kind of conversations around GraphQL and serverless, and also just Hasura. And kind of just optimizing data fetching and talking about a lot of different stories from Hasura users, about how they've been building applications with Hasura, what kind of challenges they've seen, and what kind of things they've, what kind of tooling they've built around it. So do check that out, and looking forward to have you there. And otherwise, thank you so much, Simona and Chris, for joining me. I hope this was fun. I got to learn quite a bit, and I hope this was useful for folks who've tuned in as well.
Thank you all for joining, and thank you for having me.
Bye, folks.
Yeah,
Stay safe.
Bye.
Bye, Chris.